Hello, guys. I hope you're all well. Yesterday, we could not have our live class, so today, in this video, we are going to learn, we are going to discuss the new section, which will be going to be your exercise 2.3. So, let's move on. So here, what are we going to learn? Let me choose. So here it says about the diagrammatic representation of a complex number. How do we represent our number line? Okay, the natural numbers, the whole numbers, the integer, they are represented by a straight line, D, which is called your number line. This is the representation for the real numbers. Now, for an imaginary number or a complex number, okay, we are discussing about the complex number. So how will it look like? Okay, so earlier we have discussed that complex number complex numbers, okay, it can be written in ordered pair. So the real number is your x. For a complex number, x plus iy, okay, in ordered pair, it can be written as x comma y, and which is nothing but for just like your coordinate plane, the abscissa and the ordinate, it becomes like a coordinate points. It becomes like a coordinate points. So we can represent it like an xy plane. Okay. Now this xy plane will be called your pillar complex plane, or this is also known as, this is named as Argand plane in honor of the this one, Jean Robert Argand. Okay, he is a mathematician from Geneva. He was born in 1768 and died in 1822. Actually, he had published this graphical representation of complex number. So this plane is also called as Argand plane. Clear up to this much? So a complex number can be represented. The x-axis will be your real. Okay, this is your x. This will be your real part, and the y-axis, this will be your imaginary part. Say like 4 plus 3i. That means 1 2, this will be your 4, and then it will go 1 2 3. So the point will come here. This will be your 4 comma 3. So this is your Argand plane, and this is how we represent a complex number in a plane. Clear? And then this plane is called your complex plane or Argand plane. Both denote the same meaning. Perfect. Now the x-axis will be your real axis in x-axis. Okay, the x-axis will be called your real axis, and the y-axis, it will be your imaginary axis. And this representation of a complex number on a complex plane is called as your Argand diagram. So if you are told to draw an Argand diagram, you have to draw this one. Now, since a plus I0, this is your a comma 0, and this will give you your real axis, and 0 plus IB, right, this will give you your imaginary axis. Okay, and then this real, it can be represented like this: a comma 0 such that a belongs to R, and the imaginary axis can be represented as like this: 0 comma B such that B belongs to R. And this the is the subset of this one, proper subset of the complex number. And again, the imaginary axis is also a proper subset of the complex number. Clear? Now, one of the interesting thing you will learn here is this one. Okay. Thing. Okay. Wait. See this one. For -2, okay, we can write like this: 2 into -1. That's fine, right? And -1 can be written as I square. So we can write 2 into I square. Now I square can be like 2I into I, right? Let's see, okay. That means where is our -2? Here is our -2. This point is our -2. Fine. Now -2, okay, that 2 is multiplied by I twice, then we get -2. That means this 2, okay, when multiplied by I 2 times, we get here. That means the angle day, what is the angle of rotation? It is like 180 degree. That means if we multiplied by I 2 times, I square, I into I. Fine. If we multiply only with I, one I, then it will turn 90 degree. After it will reach here. This will be your 2I. And if you multiply with another I, it will give us -2. Again, if you multiply with another I, that means we have already got -2I square. Okay. Now, if it is, we already got 2I into I, which is, this is your nothing but -2. Again, if we multiply with I, one I again, one more I, then it will reach to here, this portion, 1 1 2. Okay, this portion, this will be your minus 2I. Wait, this will be your -2I. Okay, this will be your -2I. Again, if you multiply -2I into I, right, so I into I is what? I square means -1. This is nothing but your minus into minus, positive I. That means it will come to its again another, its original position, +2. Fine. So for a number Okay, it's I times multiplied the angle that it makes is 90 degree. It rotates in anti-clockwise direction 90 degree. Fine. 2i, it will be your 90 degree. Again 2i d, if you multiply, it will reach 180 degree, the straight line, this one. Again if you multiply d, it will become 270 degree. That means 0, 90, 180, 270. Then again if you multiply 4 times d, it will be 360 degree. That means it will come to its original position. Fine. So you see here, if 2 is multiplied by I, then it is minus 2. If 2i is multiplied by I, then it is minus 2. Right? Again further it rotates, minus 2 by I, it comes to minus 2i, and then it comes to its original position. So you can read this section by yourself, you can understand this one. Figure 2.63 and figure 2.64. Clear? Read this portion, then you will understand. Okay. Then now we'll come to our next section, which is your very important, that is your modulus. Modulus of a complex number. So what is the modulus? Here we will take the positive d. So modulus of a complex number. So let us take a complex number z equal to x plus iy. Then, okay, pz, that means p comma xy. Pz means a complex number d. So the complex number can be written in our ordered pair x comma y in the Argand plane. Now let's say that pm, p and then m, it per the x-axis. Okay, ox axis. It is perpendicular to the ox axis. Fine. Okay. Now OP is joined. This is OP is joined. Then what will be fine? Position of these two, distance of these 2 points O and P. Distance formula plus 9. So OM is square, then PM is square. D. Use, then OM is nothing but your, where is OM? OM is nothing but your x distance. That means your x is square. PM is nothing but your y distance, right? Y square, y unit. Now this distance p from the origin is called the modulus of the complex number. So modulus is nothing but the distance from the origin to the point. This is your modulus of the complex number z equal to x plus iy, and it is denoted by the letter r, or sometime this one, z within 2 bar, z modulus. So if z equal to x plus iy, then its modulus r or zd, then it will be square root of x square plus y square, and this is a non-negative real number, because if x is negative but its square will become positive, so that is why it is called non-negative real number. So whenever we put this symbol, okay, 2 bar, right, this modulus symbol, it always gives us the positive number. It is non-negative. Fine. So modulus is nothing but the distance from the origin to the point of the complex number. Do you understand now what is modulus of a complex number? So if for 1 marks D, if it comes what is called the modulus of a complex number, then you say this one. The distance of the point P from the origin, okay, is called the modulus of the complex number z equal to x plus I. Some of the rock example is given here. Find the modulus of the following number z equal to minus 2i, 7i, 2 minus 7i, z equal to 2 minus 7i. So 2 minus 7i minus a plus ib form, okay, 2 plus I minus 7. So this becomes your x, this is your y. So 2 square plus y square root over 53. This is the modulus. Fine. Okay. Now will come the properties. What are the properties of a complex number? So the first property, it says that the modulus of the modulus of the conjugate, okay, conjugate of a complex number, the modulus of the conjugate of a complex number is equal to the modulus of the complex number. So the modulus of the conjugate and the modulus of the complex number both are same. Okay, so if z is a complex number, then modulus of z is equal to modulus of z conjugate. This is our first property. So the proof is given. So in you write down proof, okay, then you write down let z equal to x plus iy be a complex number, then z bar equal to x minus iy. So write in a plus b form x plus I minus y. Fine. Now you find out z bar, z no, not z bar, z modulus. Use the formula. Then you find out for modulus of z conjugate d. Then x square, and here our y is minus y. So minus y square. Minus y square is what? X square plus y square, right? So now you see here z is also root over x square plus y square. Z conjugate modulus is also x square plus y square. So therefore, modulus of z is equal to modulus of z conjugate. Conjugate of z. Modulus of conjugate of z. Fine. The first property, you understand? Now let's come to the second property. What is the second property? The modulus of a complex number is equal to the modulus of its additive inverse. Additive inverse means negative, the minus. So modulus of z and modulus of minus z both are equal. Let's see the proof. So for z equal to x plus iy, its additive inverse is minus z. So multiply both by minus, then we will get minus x minus iy. Now you find out for z. Okay, this is using the formula, modulus formula. Then you find out for minus z modulus here, minus x square and then minus y square, and both will give us x square plus y square. So therefore z is equal to modulus of minus z. Fine. Now let's come the product z into z. Okay, so the product of a complex number with its conjugate is equal to the square of the modulus of the number, that is for a complex number z and z conjugate, if you multiply, then we will get modulus of z square of the modulus. So this is our third property. Okay, if you multiply the complex number and its conjugate, then you will get in the answer modulus of z square or square of the modulus z. So say let z equal to x plus iy, then z bar will be your x minus iy. So modulus of z will be x square plus y square. Fine. X square plus y square. Then now you multiply z into z conjugate. We will get x square plus y square. See, x square minus I square. Then I square is minus 1. So minus into minus become plus. So x square plus y square. So this is our left hand side. Okay, z into z. Then now on the right hand side we will find out modulus of z square. X square plus y square root over whole square. Modulus of z is root over x square plus y square. So it's whole square. Then root and then this is square. Okay, they cancel it out. Then we will find x square plus y square. And see, this is your number 1. This is your number 2. So from 1 and 2 we can say that left hand side and right hand side are equal. So the product of the product of complex number z and its conjugate, it gives us the square of the modulus of z. Let's come to our next property. The modulus of the product of two complex number is equal to the product of their moduli. Moduli means plural of modulus. Okay, क्या है? दो complex number its product, okay, and their modulus. So modulus of the product of two complex number, it is equal to modulus of its complex number their product of the modulus, okay, of its complex number separately. That means say, okay, z1b, you see here, how do we get here? z1 into z whole square d modulus of z1 into z whole square. So from modulus, this use this formula C. Okay, z square is what? Z into z conjugate. So here also z1 into z2 modulus. So z1 into z2 and its conjugate multiplied. Fine. We are using property number 3. Okay, this one. Then this one we can separate conjugate the property, conjugate property. So z1 conjugate z1 conjugate z2. Then we can use distributive the z1 z2, okay, both are multiplied, so we can write together, and here also we can write them together, z2 z2, arrange it. Then z1 z2 again same, using this formula property 3 the z1 and conjugate of z1, it will give us modulus of z1 square. Z2 into z2 conjugate, it will give us modulus of z2 square. So we got this one, z1 into modulus, okay, modulus of the product of z1 z2 is equal to modulus of z1 into modulus of z2. This is our fourth property. Now same goes to our division. Okay, two complex numbers z1 z2, and if we divide, then it will give us z1 and z2, okay, divided together within modulus of the division of z1 and z2. It will give us separately modulus of z1 divided by modulus of z2. So come here, we can write z1, okay, we need z2 also, right? So we will bring z2 here. We need z1 by z2. So for z1, how we write? We multiply both the denominator and numerator by z2. Z2, Z2 cancel out. So modulus of Z1, we got this one. So modulus of Z1 will be modulus of Z1 by Z2 into Z2. So multiplication, that one earlier formula, we can write them separately. So Z1 and Z2 modulus, and then Z2 modulus separately. Then you bring this Z2 other side. This is Z1 modulus, this is Z2 modulus. You bring to the left hand side, then we get modulus of Z1 by modulus of Z2, and here we get Z1 by Z2 modulus. Fine, do you understand? So modulus Z1 by Z2 modulus is modulus of Z1 divided by modulus of Z2, provided that Z2 is not equal to 0. That means the denominator should be non-negative number or non-zero number. Okay, should be non-zero number. Or here it says you can do this one also using this formula also. Okay, by taking Z1 and Z2 as x1 i1 y, Z2 as x2 y y2. Okay, you can prove this. Next is if Z, which is a non-zero, then its inverse. Okay, Z inverse is conjugate of Z1 divided by square of the modulus Z. This is our property F. So earlier from property 3 we know that multiplication of Z1 Z2 Z and its conjugate, it give us modulus of Z square, the square of the modulus. So what do we do? Both नीचे में हमको Z square चाहिए, right? So for this one we will multiply both sides by modulus of Z square. So dividing by modulus of Z square, we get Z into, हाँ ये और ये चाहिए हमको, मिल गया अभी देखो, राइट इस तरफ होगा modulus of Z square, modulus of Z square. If you cut them you will get 1. So on the right hand side we got 1. अब ये Z separate है ना, उसको right hand side में ले जाओ and then it will become 1 by Z. ठीक है, Z conjugate and then modulus of Z square, and 1 by Z is nothing but your Z inverse. So Z inverse is equal to conjugate of Z divided by modulus of Z square. ठीक है, then this is another property, okay, that the modulus of the sum of two complex number, so Z1 plus Z2, okay, modulus of this sum, this can never be greater than the sum of the moduli. It will always be smaller. Okay, modulus of this one together, if you add them and you take the modulus, then it will always be equal or smaller than when they are added separately. Modulus of Z1 plus modulus of Z2 कभी भी 12 नहीं हो सकता. So this will be important for your class 11. You will get this one. So in here it says probe is not required, so just you know it. Okay, same as the difference is always greater, okay, cannot be smaller than this one when subtracted separately. ठीक है, they can be either equal or it can be greater, but never smaller. And same as for the addition, it will always be smaller, cannot be greater, okay, than the sums of the complex number when added separately, taken modulus separately. Then again this one also, okay, modulus of Z1 Z2 subtraction it is always smaller than when they are added separately. ठीक है, when they are subtracted then वो बड़ा होगा, कहाँ है हाँ, when they are subtracted separately then ये वाला बड़ा होगा, z1 minus z2 modulus of z1 minus z2 बड़ा होगा, लेकिन अगर एडिशन हुआ तो वो छोटा होगा. ओके, it will be equal or it will be smaller. Now let's come to our last property. So for two complex number z1 and z2, ठीक है, z1 plus z2 whole square, okay, their modulus square plus z1 minus z2 modulus square, this is twice of modulus of z1 square plus z2 square, modulus of z2 square. तो square the a plus b whole square plus a minus b whole square, this is 2a square plus b square. ठीक है, चलो देखते हैं. Let z1 is x1 plus iy1 and z2 is x2 plus iy2. So z1 plus z2 will be x1 i1. चलो यहाँ पे छोटा कर दिया दी. You write one more step. z1 plus z2 the square, z1 minus z2 modulus square twice of z1 square plus z2 square. Let z1 equal to x1 plus iy1. Then z2 will be your x2 plus iy2. तो अभी z1 plus z2 करेंगे, z1 plus z2 x1 plus iy1, ठीक है, प्लस x2 plus iy2. तो अभी रियल पार्ट एक साथ लिखेंगे, I कॉमन द इमेजिनरी पार्ट y1 plus y2, सेम z1 minus z2 x1 plus iy1 minus x2 plus iy2. So we can write x1 minus x2 plus I common y1 minus y2. Now let's ठीक है. Then now from here you can do this one left hand side, z1 plus z2 whole square plus z1 minus z2 whole square. तो z1 plus z2 क्या है, x1 plus x2 x square plus y square. Do you remember? Modulus of z is root over x square plus y square. Then modulus of z square will be x square plus y square. So from here it comes this one. Modulus of z square है तो रूट ओवर चला जाएगा, रहेगा खाली x square plus y square. ठीक है, सेम. x1 minus x2 whole square plus y1 minus y2 whole square. Now you use the formula. The x1 and x together we can write x1 plus x2 whole square plus x1 minus x2 whole square plus y1 plus y2 whole square minus y1 minus y2 whole square. ठीक है, now break the formula. What do we will get? x1 square plus 2x1 y x2 plus x2 square. ठीक है, plus here also x1 square minus 2x1 x2 plus x2 square. ठीक है, plus here also same y1 square plus 2y1 y2 plus y2 square. Then you have your minus the not minus, this is plus only. Here also y1 square minus 2y1 y2 plus y2 square. तो ये दोनों दो माइनस काट जाएगा. Here also this one and this one become minus. तो हमको क्या मिलेगा अभी 2x1 स्क्वायर आएगा, x1 x1 2x1 स्क्वायर plus x2 x2 2x2 square plus here also 2y1 square plus 2y2 square. So you can take 2 common from here, है ना. अभी x और y y1 वाला एक साथ लिखेंगे. तो x1 square plus 2y1 square 2x2 square plus 2y2 square. तो 2 common, x1 square plus y1 square 2 common x2 square plus y2 square. ठीक है, now x1 square plus y2 square, that means क्या है ये x square plus y square and this is nothing but your z square. मतलब कि ये होगा तुम्हारा मॉडुलस ऑफ z1 स्क्वायर एंड ये हो गया तुम्हारा मॉडुलस ऑफ z2 स्क्वायर. ठीक है, एंड फ्रॉम हियर यू कैन टेक 2 कॉमन. तो modulus of z1 square plus modulus of z2 square, and this is nothing but your right hand side. So write down therefore, last में देखो therefore z1 plus z2 modulus square equal to 2 z1 square plus z2 square. ठीक है, then this is your proof. Okay, last property pz. Some of the workout examples. The examples one you write down on your notebook. ठीक है. Examples are also very important. See, if modulus of z1 is equal to 0, okay, proof we need to prove. If and only if z is equal to 0. And then number 2 is modulus of z is greater than equal to 0. To पकड़ा ही let z equal to a plus ib. That modulus of z will be square root of a square plus b square. Now, say, suppose z modulus of z is equal to 0. Then this one will be equal to 0. And a square plus b square equal to 0. A square will be minus b. तो ये दोनों 0 होगा. A square plus b square कब 0 होगा? When both are 0. If one is 0, another is non-zero, then we will not get 0. So since some of the two positive numbers cannot be 0, so a is equal to 0 and b is equal to 0. So therefore z a plus ib 0 plus i0 equal to 0. ये हो गया तुम्हारा converse. Even only if बताया है तो conversely also you have to go. So conversely let z equal to 0. Then a plus ib is equal to 0, which means that a equal to 0, b equal to 0. So property of modulus of z will be a square plus b square 0 square plus 0 square equal to 0. ठीक है. Next is what? It will be greater modulus of z is greater than or equal to 0. चलो देखते हैं. A plus ib. If a and b are 0, then z equal to 0. So modulus of z equal to 0. अगर a और b दोनों 0 है. लेकिन if one of them is non-zero, okay, if either a is not equal to 0 or b is not equal to 0 or both are non-zero, then in that case a square plus b square is not equal to 0, it is greater. So we can say that in this case is a positive number. So modulus of z is greater than equal to 0. अभी प्लॉट करना है. एग्जाम्पल 2. प्लॉट द नंबर्स -3 plus 3i 1 plus 2i 5 plus i on the Argand plane, and so that they are collinear. Collinear मतलब they are straight line. Then again we also need to find the conjugate. the conjugate निकालने. चलो देखते हैं. So let the point represented by this, okay, letter p, q and r respectively. So the first one is what? P is -3 plus 3i. Here you write down p, okay. Like this. Oh, no need. We are here, we are doing this one. We are not writing the point. We are converting into ordered pair, complex number into ordered